Question 5. This question is taken from Cambridge IGCSE Additional Mathematics, June 2015, Paper 2, Question 9. A. Find the set of values of x for which 4x squared plus 19x minus 5 is lesser or equal to 0. We have an inequality. 4x squared plus 19x minus 5 is lesser or equal to 0. And we are asked to find the range of values of x where this happen. First, we factorize the inequality. Four can be 1 and 4, 2 and 2. 5, there's only one combination, 1 and 5. So I will write down 1 and 5 first. As for 4x squared, we need to do trial and error. Let's try 1 and 4. X and also 4x. For here, we will obtain a 5x. And here we will obtain a 4x. We need to obtain a positive 19x. Hence, this is not the combination we are looking for. Let's exchange the position of 1 and 4. For x and also x. Here we will obtain a 20x. And here we will obtain 1x. To get a positive 19, we add 20 minus 1. Hence, this is the combination we are looking for. Positive 20, it will be over here, and negative 1. And lastly, we need to check negative and positive. We will get a negative. When 4x minus 1, x plus 5 is equal to 0, 4x minus 1 is equal to 0, 4x is equal to 1, x is equal to 1 over 4, or x plus 5 is equal to 0, x is equal to negative 5. We will solve this inequality by using the graph sketching method. We draw the x-axis, and the x-intercepts are negative 5 and 1 over 4. Our a value is a 4, which is greater than 0. Hence, this is a smiling curve. And we are looking for the area where this expression is lesser or equal to 0, which is this part. Therefore, the range of values of x is between negative 5 and 1 over 4. B1. Express x squared plus 8x minus 9 in the form bracket x plus a squared plus b, where a and b are integers. We are given an expression in general form, and we need to express it in vertex form. The a value for this expression is already 1. Hence, we can continue from here. First, we open a bracket. We put an x here and a square here, plus b over 2 minus 8 over 2 square minus 9. We simplify it. X plus 4 square minus 4 square minus 9, which is equal to x plus 4 square minus 16 minus 9, and therefore x plus 4 square minus 25. B2. Use your answer in part 1 to find the greatest value of 9 minus 8x minus x squared and the value of x at which this occurs. We are given an expression 9 minus 8x minus x squared. And if you notice, this expression is exactly the negative of the expression given in B1. Let's factorize out the negative 1 and rearrange it in the general form. Negative x squared plus 8x minus 9. Hence, we can use the answer in vector form that we obtained just now in this question directly. Negative x plus 4 square minus 25. But remember, we need to expand the bracket. We get negative x plus 4 square plus 25. We are asked to find the greatest value of this expression and also the value of x at which this occurs. Our a is a negative 1, which is less than 0. Hence, it is a crying curve. A maximum point is obtained. If we let this expression be y, greatest value of y indicates that we are looking for maximum y. In this case, maximum y is 25. This value can obtain from the vertex form directly. Maximum y will occur at the symmetrical line. Hence, to obtain the x value, we solve for the symmetrical line. Symmetrical line. X plus 4 is equal to 0. Therefore, x is equal to negative 4. B3. Sketch the graph of y equal to 9 minus 8x minus x squared, indicating the coordinates of any points of intersection with coordinate axis. We are asked to do two things. First, we need to sketch the graph. Then, we need to indicate the coordinate for x-intercept and y-intercept. We are halfway done. Some of the information we already obtained in B2. Hence, we will just continue from there. We already obtained the shape, the maximum value, and the axis of symmetry. By combining the axis of symmetry and maximum y value, we'll obtain the maximum point. Negative 4, 25. To obtain the y-intercept, x is equal to 0, y is equal to 9. This value can obtain directly from the given expression. Then we need to find the x-intercepts. Y is equal to 0. 0 is equal to negative x plus 4 square plus 25. We bring negative x plus 4 square to the other side. We get x plus 4 square is equal to 25. Square root both sides. X plus 4 is equal to plus minus square root 25, which is plus minus 5. Therefore, x is equal to 5 minus 4, and also x is equal to negative 5 minus 4. For x is equal to 5 minus 4, x is equal to 1. For x is equal to negative 5 minus 4, x is negative 9. Let's gather all the informations. This graph has a crying curve. The maximum point is negative 4, 25. Y-intercept is 9. And the x-intercepts are 1 and negative 9. First, we draw the x-axis and y-axis. Then we plot the maximum point, negative 4 and 25. Negative 4, 25. Now we have an idea. The graph is a crying curve. The graph will look like this, or maybe this. We have one negative and one positive x value respectively. Hence, it should look like the second curve. The curve cuts the x-axis at -9 and 1. And it also cut through the y-axis at 9. Question 6. This question is taken from Cambridge IGCSE Additional Mathematics, June 2013, Paper 2, Question 8. A. Sketch the graph of y is equal to modulus x minus 2, x plus 3 for x is between -5 and 4 and state the coordinates of the points where the curve meets the coordinate axis. We are given an equation y is equal to modulus x minus 2, x plus 3, where the x is between -5 and 4. We are asked to sketch a graph of this curve. Before we can sketch the modulus graph, we will sketch a graph without the modulus. Then we will turn all the negative y value into positive y value. This is the equation without the modulus. Let's prepare some point to draw the curve. Let's find the y-intercept and x-intercepts first. When x is equal to 0, y is equal to -2 multiplied with 3, which is -6. When y is equal to 0, 0 is equal to x minus 2, x plus 3. X minus 2 is equal to 0, x is equal to 2, or x plus 3 is equal to 0, x is equal to -3. The range of x is not to infinity, hence we need to find the coordinate for the smallest x and the greatest x as well. When x is equal to -5, y is equal to -5 minus 2, -5 plus 3. We simplify it, -7 multiply with -2, negative and negative we get a positive, 7 times 2 we get 14. When x is equal to 4, y is equal to 4 minus 2, 4 plus 3. Which is 2 times 7. And we get 14 as well. Let's put all the coordinates that we obtained into a table. We have 5 coordinates in total. -5, 4, -3, 0, and 2. When x is 0, y is -6. When x is 2 and also -3, y is 0. When x is -5, y is 14. When x is 4, y is 14. Let's draw the x-axis and the y-axis. Our maximum y for this case is 14. We have 2 of them, -5, 14, and also 4, 14. -3 and 2 both have 0. When x is 0, y is -6. For this point, I will plot it after sketching the curve. Since we have 2 points with the same y value, we can find a symmetrical line. For example, we can use -3 and 2. X is equal to -3 plus 2 divided by 2. This is the formula to find the midpoint. Therefore, the symmetrical line is x is equal to -1/2. The symmetrical line will be somewhere here. So why do I search for the symmetrical line? This will actually help me in sketching the curve. I will know the middle of the curve, hence I can sketch the left side and the right side more identically. This is the minimum point, and our y-intercept is -6. This is not the end yet. This is not the curve that we are asked to sketch. We need to sketch the modulus of this curve. So instead, I will use red color to sketch the graph that the question is asking for. The negative part need to flip up. And the positive parts remain. The y-intercept become +6. B. Find the coordinates of the stationary point on the curve y is equal to modulus x minus 2x plus 3. Since we already obtained the axis of symmetry just now, which is x is equal to -1/2, stationary point occurs at the axis of symmetry. To find the coordinates of the stationary point, we just substitute x equal to -1/2 into the equation y. X is equal to -1/2, y is equal to modulus -1/2 minus 2, -1/2 plus 3, which is equal to -5/2, 5/2. We simplify it. Negative and positive, we get a negative. 5 times 5, 25. 2 times 2, 4. And because we have a modulus, the y value is 25/4. Therefore, in this case, our stationary point or the turning point is -1/2, 25/4. For this case, we cannot consider this point as a maximum point because we have other points greater than this. Hence, we can only say it is a stationary point or the turning point. C. Given k is a positive constant, state the set of values of k for which modulus x minus 2 x plus 3 is equal to k has two solutions only. K is positive. Y equals to k has two solutions only. To check the number of solutions for y, we can do horizontal tests. That is, we draw a horizontal line on the graph and see how many points it cuts through. Let's do it with an orange line. For the first line, the orange line cut through the graph at 2 points. Second line also the same, 2 points. The third line, 3 points because it also cut through the turning point. The fourth line, we have 4 solutions, 1, 2, 3, 4. The fifth line is also 4 solutions. And the last one, the line y equal to 0, we have 2 solutions. This point and also this point. Hence, the area where the curve has only 2 solutions is here. And also the line y equals to 0. when y is greater than the turning point, 25/4, but not equal to the turning point. If it equals to the turning point, it will have 3 solutions. Other than this, y equal to 0 also has 2 solutions. But the question states that k is greater than 0. Hence, this answer is ignored and we accept only this answer.